welcome back. Welcome back to my channel, a little bit about everything. And today I'm going to talk about spur gears. Okay, there are many different type of gears. They all have a general purpose. It's to transfer rotating motion into work. They are also used for gear reduction. Well, let's say you had a 1 horsepower motor and you have a gear ratio of 1:1 on the input and output. Well, you're getting 1 horsepower on the output, and the torque is going to be the same as the motor. Now, if I had a gear reduction, let's say I have a 3:1, 1 on the input. Then if my input's revolving at 1000 RPM, my output's going to be 1/3, 333.333 RPM. I lose speed, yet I gain torque. And torque is what you need to do work. So, as far as gears go, the spur gear is a straight gear. If you look at it sideways, it's like this. Okay? And that's a straight spur gear. These are noisy. They're not made for high RPM or constant use like in an automobile. Like the old cars from the 30s and 20s, 1920s and stuff, 100-year-old cars, they had straight gears in there. And so does a tractor, like older tractors. But when they start humming down the road, you can hear those gears humming. What they use today are helical gears. So you would have your gear like this, and they're at an angle. Well, what this does for you is, as your gear rotates, the point of contact switches. So it's always in constant mesh. So are the spur gears. But these are always constant mesh, and they're not transferring power on the whole length of the tooth. They only make contact in a small area. As the gears go like this, the contact area is not as great. It's just as strong, but it's not as great. So that reduces the humming noise that you would get in a gear. And what I'm going to try to do is make a fly cutter, and the cutter is going to be shaped as an involute gear, okay, and a little bit about the involute shape, okay, is if you look at a circle and you take the radius, like you can divide it into 4 or however many slices you want, okay. If I draw a radius line to my outer diameter, my circumference of my circle, the length of the chord straightened out perpendicular to that radius gives me a point. And I do that continuously, like for for a couple of spots till I can actually connect the dots and get an involute shape. Okay? And if let's say that's a gear, I take a section of this shape, let's say I cut it through here, like that. Well, if I lay down this pattern here, I get that. So if I mirror this, I do it again. Okay? And that's the shape of an involute gear. But you also want to put a little radii or fillet at the root. And this being because anything with a square corner, when there's work being done or it's under load or stress, if you get a crack in that gear, it's going to be in a sharp corner. So you don't want to leave sharp corners in that tooth pattern, okay? And this circle here is the pitch circle. Oops. Well, I finished machining my MT3 taper, and I threaded it in the interior, and off of the board it's 3/8 16 national course. That's what the drawbar on my mini mill uses, right? This is a fly cutter for cutting gears. I'm going to cut a notch in here, like mill some of this down to at the point where I just have to cut a notch, and you put your cutter in there. And you give yourself a 16th of an inch larger than the 3/8 or than the quarter. You go to 5/16, so that way when you grind your cutter, you can offset it by that much, by 1/16 of an inch. That will create a relief angle in the back of the cutter. Okay. Now, this isn't running true. The MT3 taper is true, but the mass at the end of it is off by a couple of thou. So I'm going to put it in centers again, if I can, and machine the large diameter. Now I think, yeah, I think it'll go in there. Yeah, and I'm going to machine that again. Probably do it this way. No, I got to do it the other way around if I want to take off weight. And I have a sleeve here for an MT3 taper. I'm just going to slide it in here, put my lathe dog on this piece, and then put the center like this and machine this end of it. Okay, that's what I'm going to do next. So this is what I'm trying to remove from the part. See the wobble
it's not that the cutter's going to be spinning that fast, but if I can machine it right the first time, like, it's not critical since I can move the cutter around. The cutter's always going to be in reference to the MT3 taper center line, no matter what, because the cutter can move. But if this was an arbor for a saw, a slitting saw or something, I'd be off by that wobble, because the blade would be on a diameter, and it would be wobbling with the end of that, I don't know if you can call it a chuck, an arbor, or it's an arbor in a sense. It holds a cutter, tool holder. So I'm going to machine this out of it. Okay. So now, as you can see, the wobble's out of it. It's trued up to the center axis, but I still got to face this off. There's still a little wobble in the front here, so I'm going to insert this into the 3-jaw chuck and then take a face cut off of this and remove the center I have on there. I do not believe I need it again, because everything else is going to be done in the mini mill. So there it's spinning, and I'm getting, looks like between 2.5, maybe 2 3/4 of thousandths of an inch run out. That's probably due to see, it shouldn't be there since I machined it in between centers. So something was a little off. I don't think there was a chip in anything, but I know the sleeve I made, MT3, isn't super smooth and it's not super accurate. There are techniques to get things bang on, and when they don't get bang on and you use those techniques, that means something's either a burr or... But that should be dead nuts since I machined this through centers. Maybe it's because of the threads on the other side. I had put a chamfer on it to start my thread, and I made that chamfer deep enough, so I thought it would be okay on a center, like to reuse it on a center. Maybe it wasn't. Maybe that's why it's off by 2/10. I don't know. I tried putting it on the spindle itself, and I'm getting 1 thou run out. Now, that doesn't mean the bore isn't bang on, okay? It doesn't mean the bore isn't bang on. I have one more place I can try it. I can try it on the taper itself. And if that's bang on, that means the bore is bang on and something's wrong with this piece here. And I'm guessing maybe since it was between centers and it was machine offset, right? See, that's... Now I have it on the MT3 taper itself, and I'm looking at my dial here, and I'm bang on. I have maybe 1/2, maybe 1/2, right? And it's oscillating. It might be a groove from the cutting. Maybe I didn't get everything with the machine file, but that's pretty bang on. So the run out in here was probably caused by the offset of the tailstock, and the spindle bore is bang on. It's just the exterior of it that's got a little 1 or 2 thou run out in it, which is not important. So that means if ever I take measurements with the spindle here to trepan the table, I have to make sure I've got something chucked in there that's true to do it with, because there's a wobble on the exterior. I can't put a collet on that and put a dial indicator on it and expect it to be bang on. For some applications it doesn't matter, for others it does. So the machining's done, and the width of the slot is 31/35. Which is close enough for my application. And this is
almost 26. The collet might have pulled down because it's not a locking collet. Or something might have moved. It's not the most rigid of setups. I got some screws for I'm going to be put some set screws I'm going to be putting through here, or grub screws some people call them, here, here, and here. I'm going to put 3 of them. Okay. I just received a cutter. Okay. I got this from where is it? There. Exercise tools. They got lots of stuff for mini mills and lathe. Nice quality tools too, right? Their high-speed steel has cobalt in it, which is very good. It's a lot stronger than regular high-speed steel. And I also got, whoop, they're the set screws. They're going to be, I believe, number 8. If I can focus in on this. No, it is number 8, National Course 32. That's what I'm going to be using. Now, I may actually have to face this off with an end mill and then put a little center with a starting bit to get the drill bit started, and then I'm going to be putting 3 holes in there. I'm just touching off the high spot so I can put in my my center drill so I can start drilling, and I'm going to go, I don't know, maybe a 1/4 of an inch on either side and put in another grub screw. Well, 2 down, 1 more to go. Oh, if I can focus. Yeah. Got the 2 first ones and I got the last one to go. So, putting in the finishing touches. There's a close-up of the 3 threaded holes. Okay. Now I'm going to insert the tool in there and see if it holds. Tool that flies around ain't no good, huh? Whoops, that won't do. Falling out the grub screw. Well, there it is.